This is the 7th video in our balancing equations series, where we are taking a look at chemical reactions and balancing them on either side of the arrow. In this particular equation, we have iron reacting with copper 1 nitrate. It's a single replacement reaction forming iron 2 nitrate and copper. And we're going to have to change this from a word equation to a chemical formula equation. Iron is simply an element, and because we see this 1 following copper, which is a metal, we know that we are going to use the stock system. We know that 1 corresponds to the copper ion. If we go to our polyatomic list, nitrate, right here, it is NO3. And I knew it was a polyatomic because of this ending. If it had "-ide", it would have just been nitrogen. So let's write down NO3 negative, and this forms iron. Again, we're using the stock system, so we know that iron in this formula has a +2 charge. There's our polyatomic nitrate. It is a -1. And copper. We're going to add 2 here because they are not diatomic elements. So now we need to figure out how these combine. Well, iron is simply going to remain as is. This is a 1-to-1 ratio. So it will combine 1 cation of copper to 1 anion of nitrate. We do need to cross and drop here. So for every 1 cation of iron, we will need 2 ions of nitrate. And we're going to put that in parentheses and add the 2 outside the parentheses. And copper stays the same. So now we now have our reaction written out in chemical formulas. We can go about balancing it at this point. Now I can follow the format that I've been doing all along and draw the line and write the elements and the polyatomics on both sides. But at this point, you should be very comfortable with looking at it first. 1 iron, 1 iron. 1 copper, 1 copper. The only difference between the 2 is we have 1 nitrate here and 2 nitrate there. So if we add 2 here, we fix nitrate, and now we just need to fix copper. So hopefully by this point you can solve some of these without having to write everything out just by looking at it. And that is our balanced equation. We've got 1 mole of iron reacting with 2 moles of copper nitrate to produce 1 mole of iron 2 nitrate and 2 moles of copper.